This class will look at the World Wide Web. It's one of a couple of classes on this topic, and ideally both should be studied with care. This one will look at issues such as the Uniform Resource Locator, but it'll look at other topics as well as we go through. But this is such an important topic that it's worth spending a little time considering it in detail. The HTML document that forms a website is defined by a URL, the Uniform Resource Locator. So the page, the HTML page, the hypertext markup language page that constitutes a page on a website is defined by its URL. The URL is how we find that page. The URL is a protocol or standard that gives the address or location of any website. So we find our way around by URLs. URLs are the way we locate information on the internet. And it's made up from the following. There is a HTTP, and then that's the hypertext transfer protocol. Then there's a colon / / So we start the address http : // In fact, the person who developed the World Wide Web, Tim Berners-Lee, an English guy who was working in CERN as a scientist in CERN, when he developed the World Wide Web, he just put in the colon / I don't think he meant it to have the longevity or the staying power that it has, but we still have colon // Anyway, the point is that the hypertext transfer protocol, HTTP, is followed by these symbols, colon // and the server address. So, for example, let's say we're talking about the BBC. So the address for the BBC is www.bbc.co.uk. Now, this address specifies the server where the site is stored and the country where the server is located. The .co.uk is known as a top-level domain, and countries have top-level domains. Oddly enough, with the exception of America, that America doesn't have a top-level domain. In the past, .com was seen as the American domain, the main American domain name, I should say. It's a bit confusing to say. Anyway, the point is that .co.uk is top-level domain for the UK. So the server address is www.bbc.co.uk, and at that address we know that the BBC site resides. That's where it is. So now we've got the full address. This is the Uniform Resource Locator for the BBC. http : / www.bbc.co.uk, and that will take us directly to that site. The last part of the URL refers to the location of the document. As I said, .co.uk, or it could be .ie in the case of Ireland, or wherever. So countries have designated symbols to indicate where they are. Now, the architecture of the World Wide Web. Well, the web is based on a three-part architecture. For a start, we have the hypertext markup language, HTML. Now, HTML is what defines each web page. Each web page is developed according to the rules of HTML. It describes the contents of the web pages on the internet. So the HTML sets out the page. It defines the page. It's got a header and a body. It's also got other parts, but essentially it's got a header and a body, and the body contains the information that the site wishes to be made public. It's also part of the architecture is that this hypertext transfer protocol, HTTP. And this provides the language that allows servers and browsers to communicate. So now we have a connection. The connection is through this particular protocol. The servers, these are the machines that serve up the web pages, and the browsers, which is what we use on our laptops or desktops or whatever we've got. The connection between the two of them is the hypertext transfer protocol, HTTP. So once we open the browser and type that in, then the browser in a sense knows we're looking for a particular address. We're looking for something on the internet. And there's a third part called the Common Gateway Interface, CGI. This is used by web servers to run a separate program that contains dynamic information, and also to format it into HTML and send it to the web server. So CGI is useful for sending dynamic information that is regularly updated, or charts, graphs, tables, whatever, something that needs to be regularly updated. For example, the one I've given here is a user at a virtual bookstore, somebody online using a bookstore, requesting information on a book. Now they enter the title into the HTML form on the website. So they're looking for a particular book. They're on a website which deals with books. They enter the title of the book onto a HTML form. Now the form is sent to the web server. When we press send, it goes to the web server. And the web server uses the CGI interface to get the appropriate book title from the database. So the server holds a database, and when the form is sent, the server, using this CGI interface, takes that information and then interrogates its database and sends back the information to the user. So CGI is a very useful tool in enabling the user to interrogate the database, to get answers to the question that he or she is posing. Now, connection to the internet. Well, the modern internet depends on the interaction of a number of levels of providers and individual users. For a start, we have the individuals, and the individuals contact the ISP, the Internet Service Provider. The Internet Service Provider is normally a company, and we subscribe to the company. The company enables us to use their facilities. And in this way we get the Internet Access Provider. This way we get national access. We get access to the web itself through the servers of the ISP. So there are various players, if you like, on the internet, starting with us as individuals, going through ISPs and getting access to the national providers in that way. The National Access Provider is connected to a very high-speed backbone. That's the language we use, a very high-speed backbone, sometimes called the spine. And this network, the very high-speed backbone network, is known as VBNS, the Very High-Speed Backbone Network Service. And it uses very fast connections. It enables us to get speedy responses, and as we put more pressure on the internet by demanding video and video conferencing and so on, there's more need to have better backbones on the internet, better connections internationally from one country to the next, or within countries using very advanced forms of communications. And there are moves not only to use fiber optics for very fast connections, but also moves to look at telephone systems to see if, for example, if very fast connections on mobile phones can be used to move data. But there are lots of proposals and lots of ideas floating around how we will get more speed. The various links use passwords and security protocols to allow access to the internet. Some of that is for security and some of that is commercial. Sometimes the ISP, for example, the internet service provider, will want to stop us unless we've got a password because that's their business. They wish to sell us that facility. Sometimes we are asked for a password for security reasons. Now this CGI, the Common Gate Interface, well, HTTP is used to move information and data around the web. It is used as a transfer protocol. That's how information is moved. The information, if you like, is on the internet somewhere. We type in HTTP and a URL, and our browser and the server finds the information and returns it to us. So we've typed in the address, http:// and the address. So it's HTTP that moves the information, that tells the browser we're looking for something, we're looking for some information here. So it's calling up the information. HTTP and XML were not designed to process the knowledge or data being transported. Processing is conducted by the Common Gateway Interface, the CGI. So HTTP and XML, both of these are used to move data around the internet. They don't process the information. The information is processed by CGI. The job of HTTP is essentially to move the information, to move it from the server to the user, to find it somewhere, get it onto the server and deliver it to the user. That's HTTP. CGI is processing the information. It's like the example with the virtual bookstore earlier. It's interrogating its database and sending back information. CGI provides a standard way for web servers to communicate with the script. So it's a protocol. It's a standard way of enabling web servers to communicate with the script. It is a program that negotiates the movement of data between a web server and an outside application, such as a database. So CGI enables communications in the background on the server side. It enables communications between a database and the server can look at the queries from the users, match the type of queries with the information contained in the database, and it's able to do that because it's got a standard. CGI can be developed using several languages. It's not limited to English. But it also can be developed in several computer languages. For example, Visual Basic, Visual C++, and so on. There is a move on the linguistic front. There is a move to introduce more democracy, if you like, into the internet by enabling languages such as Mandarin and Hindi and so on, enabling these to be able to use the internet in that language, and of course that will increase the speed at which the users in those countries can access the internet, because they don't have to wait for it to be translated into a foreign language and perhaps back into theirs. So there are lots of moves along those lines. But in terms of computer languages, it uses Visual Basic and C++. It also uses Perl and so on. So there are various computer languages that the CGI can use in order to conduct its business, in order to interrogate the databases or find the information or process the forms that the users have sent. The CGI is the one that's doing the work in the background. The HTTP is simply providing the information. It's pulling the information off the server and giving it to the browser, if you like. It's bringing the information back. But the CGI is the one that's doing the heavy lifting. CGI is the one that's doing the work, interrogating databases, matching up queries with information on the site and so on. So why is the World Wide Web becoming more popular? Well, the development of simple hypertext protocols allow easy use. So the hypertext protocols are easy to understand. They're fairly obvious. Once we type them in, we know what we're looking for. If we type in http://www.bbc.co.uk, we know what we're going to get. So it's almost intuitive. So it's a simple protocol. The interface is friendly and encourages extended use. It's not difficult. Once we remember that HTML is the structure of the page and HTTP gets us what we're looking for, we don't really even have to consider CGI. It runs somewhere in the background. It provides the information that we want. We're presented with a form, we fill out the form, we fill out our query, press the send button, and CGI will work on that. And amazingly, almost instantaneously, return the information to us. So it's friendly, it's straightforward to use. Information from various sites can be combined through hyperlinks. It's not linear. We don't have to go from one site to the next to get where we're going. We can jump from one site to some completely different site. We can just follow the hyperlink. And information can be acquired very fast, very efficiently through the use of hyperlinks. The hyperlink, we simply have a hover over button or an underlined link, and we click on it, and magically we've jumped to a completely different site. But we are following our interests. We're following our query. Our query is to find a certain piece of information, and the hyperlinks will enable us to jump to where we want to efficiently. And there are increasingly sophisticated search engines. Google was a main driving force in this at the start. Google introduced the idea of bots and all sorts of algorithms for searching and enabling fast, speedy collection of data. And now other search engines like Bing are coming on board, who are offering also very fast, very efficient searches. So the facilities are there for us as users to find the information that we're interested in. Search engines have evolved into large sites offering many services such as email, personalization features, chat rooms, stock quotes, local news and weather. These, by the way, don't apply to Google. And these have developed the idea of internet portals. So Yahoo is a good example of this. When we go to the Yahoo site, we can look up stock markets, and we can get charts from the stock markets. We can get local news, and we can personalize the site to present information in the way we want it. and we could use the Yahoo email service. A portal in the past was quite a simple idea, perhaps related to a local area. It could be a part of a small town, perhaps. A small town could be a portal. It could contain information about the various shops and businesses and the community and so on. And people would access that site for information about that area. It was a bit like a local newspaper. So it would contain links for the businesses and discuss local issues and so on. Now we've got this development of sites like, for example, Yahoo, where we have chat facilities, business reports, local news, weather, we've all of this, and we get it all on the one site. So it's very similar to this old concept of a portal. Let's talk about portals for a second. Portals take many forms. For example, communication centres, service centres, virtual shopping malls, town centres, and news hubs. And these are, to some extent, what we find on a site like Yahoo. They have attracted a great deal of attention and are popular amongst advertisers because people can go to one site and find virtually everything they want about that local area. The portal may not be based on a geographic area, on a town or whatever. It might be based on a product. So some industry, collection of companies might come together to form a portal which talks about that particular product and the market and the background and who's involved and jobs available and so on. That could be a portal. It's essentially a one-stop location for a variety of products, services and information. That's what a portal is. It's a one-stop location. The web is an inexpensive source of information. When we think about the information we can get on the web, just by accessing the web and clicking a few links, it's phenomenal. So it's a very inexpensive source of information. We can get video lectures from Nobel laureates. We can find information on obscure topics. We can perform searches for very rare products or whatever. So it's a very inexpensive source of information. It's developing e-commerce and business-to-business opportunities. I say it's developing. It has developed, but it's continued to develop. The process never stops. There's a constant evolution in the context of the World Wide Web. Facilities are getting better in terms of user experience. So not only do we have auction sites like eBay, but we have sophisticated sellers like Amazon, and we have many sites that enable purchasers, buyers and sellers to come together for the purpose of commerce. And also security is improving. So we tend to have more confidence in the use of the internet for payment purposes. The development of secure electronic transactions, SET, has improved confidence and security in the web. But there are all sorts of security measures that companies take in order to facilitate purchasing online. Secured socket layers and all sorts of encryption can be used to secure the transaction. And even credit card companies indemnify purchasers. I think indemnify them if there's any issue about fraud or any issue of identity being stolen or that sort of thing. So it's worth looking into exactly what is covered in the context of credit card companies. But nonetheless, there is increasing awareness of the need for security, and the security industry is stepping up its efforts, making it more difficult for criminals to intervene in this type of development. There are still issues to be resolved. There's government regulation regarding security and confidentiality. Companies may save information about us. Companies may even sell the information they keep about us. When we click on a site, that may be recorded somewhere and perhaps sold on to other people, because we have clicked on certain sites means we're interested in those particular sites. There are issues about confidentiality. We like to have private lives. We like to get on with our life and not be spied upon. So there are issues about regulation and about security. There's also issues about taxation on the web. Because the web operates globally, it's difficult to know where tax should be paid. And the tax authorities have got problems about levying the appropriate amount of tax. There's also an issue about digital cash and the conversion rates from one currency to another, and the use of smart cards and so on. So the governments throughout the world, that is, must always be aware of the need to fine-tune their regulation, to develop and fine-tune their regulations. Database integration is a big topic. The use of databases on the web can be facilitated by what's known as middleware. This form of software acts as a middle operations gateway between the client and the servers operating the websites. What it means is that when we access a site, we're able to request information. The Common Gateway Interface, CGI, will do its work in the background, perhaps interrogating databases and bringing back the information that we require. So there is this idea of middleware. It's a piece of, if you like, software that's between us, the users, and the database. But once it's in place, then the database is in a sense integrated into the site. The database can take a central role in the site, and we can go in and interrogate that database. Middleware operates as a translator of structured data. It translates the structured data, the data of the database. It translates that, enabling structured data to be reprocessed and then transmitted in a semi-structured format via the web. You see, if we got back results from a database that were not reformatted and polished, then we would have very terse responses. We might even have responses such as first name, second name, surname, or whatever, address, email address, whatever we're looking for. And these would be perhaps in columns. Well, it doesn't look very nice. We're only looking for one piece of information. We might want to, for example, find out what the stock level of a particular item. Is it in stock? And when we perform the query, we get back that information. Yes, there are 10 of these currently in stock. Would you like to place an order? It would be not very nice if we made the query and we got back current stock level is that. Full stop, that's it. So we want something which is more user-friendly, and we use middleware to facilitate that. It translates the information of the database into something we can use and something we can link to. It's friendlier. There are a number of software middleware packages that permit small-scale exchange of structured data between databases. Of course, that's the end game in a sense. If one database can link to another database, if they use a common standard, and at the same time they enable us to query the database and get back information that is easily read, easily understood, up to date, accurate, etc. But if the databases can link, if for example a company makes components for the car industry, its database may need to be linked to its suppliers to make sure that they've got the raw materials and the components that this company needs. And the company may also need to link to the final producer of the cars to see what they've got in stock and to see what their current production levels are. So industry is using databases much more extensively. If the databases can be linked in this way, then one company can access another company's database. Obviously this depends on trust, it depends on the agreements that the companies have between them, and the access rights and what the people viewing the database can do. Perhaps they can just view. So it facilitates information and the flow of information between interested parties, and that is very important. Examples are Oracle and Sybase and structured query language and so on. These are embedded into HTML. So the HTML page, the web page, the HTML page can design HTML forms which then enable one business to query another business's database if they're allowed to do so. But also bring back the information to perhaps the final user, the consumer of the product. Bring back the information to that person in a friendlier format. It converts it from, if you like, computer speak to something we would recognize as a bit more friendly. The configurations of databases, well, two worth noting because of ease of use with databases as well as the general office software. One configuration is known as the thin client system. This is a PC on a LAN, a local area network, that does not have a hard drive. It's sometimes known as a dumb terminal. The dumb terminal means it's just an access point. Files are stored on the network server. There's nothing stored on the system that's been used. It's just a dumb terminal. It's a thin client system. So it's just access. It's a monitor perhaps and a keyboard and access, perhaps a box to give it access to the server. But itself, it doesn't have any information stored on it. There's also the fat client system, which stores applications and files on a desktop. So this would be a desktop computer or a laptop which has applications. It could have Microsoft Office, it could have different operating systems, could have Linux or whatever. This configuration is efficient since software upgrades are performed on one machine only, and also one machine requires upgrading. So a fat client system stores applications and files on a laptop, on a desktop or a laptop. And if other systems are connected to it, then of course once the software has been updated and any errors have been removed, anyone else connected to it will have the advantage of being able to use that software and knowing that it's already been updated. There's also multimedia and the World Wide Web. The web enables transmissions that utilize both audio and video. There's also movements towards virtual reality and three-dimensional presentations, and there are different languages that are developed to try and help with these. And there's the use of 3D browsers. These are good perhaps for design work, computer-aided design, CAD, or for design work in terms of the building trade, where architects can visualize more fully what their designs would look like, and so on. These are not fantasy. These are in existence. These can be used now, but they are constantly improving. They're constantly evolving. For most people, the idea of multimedia, being able to get videos, the YouTube experience, to be able to get television or sound or radio online is a major step forward in the integration of the web to more traditional media. Streaming technologies, the use of streaming technologies for video and audio, these have improved immensely over the last probably 5 or 10 years. Well, certainly out of all recognition. The quality of the sound, the quality of the videos now are in high definition, and they'll probably go to 4K and who knows, 8K eventually. And there's very little buffering. With fast networks, there's less need to wait for a big buffer to develop to give continuous run. There's less need for that with fast networks. The audio and video data on the buffering point, if it's cached locally, to compensate for fluctuations in internet connectivity and to give continuity. So that's the idea of buffering. Buffering means the data is downloaded and stored locally, stored on the laptop or stored on the desktop, and when enough of it is buffered, it could still be streaming down, still coming down, but enough of it is buffered, then the video would play. So you'd have continuity of the video and good quality video. But with faster connections, there's less need for large buffers. The data is digitized and compressed to enable delivery, but obviously the faster the connection, the better the result. In fact, streaming really requires a very fast connection. Videos would need between 300 and 500 kilobits per second. That would give good quality, but it depends also on the quality of the video that's been streamed. If it's streaming in high definition, then certainly the upper end of that. Like everything with the internet, I suppose the more there is, the better it is. Now, there are various products exist for the purpose of audio video delivery over the net. Streamworks, Video Live, CU-CME, there are many of these. That list we've got there is inadequate by a long shot. There are many, many of them which enable video conferencing, voice over IP, VoIP as it's called. There's Viber, Line. I can think of many off the top of my head. Essentially, if you want to get a list of these, just simply go online, go into a good search engine and type in what you're looking for, and it'll list out a lot of products that are available, and a lot of them are free to use. I mean, for example, Skype is free to use, and it's a video client, a one-to-one video client. It's possible to make a call, see the person you're speaking to, and do it in real time, and it's free. One of the most popular formats is MP3 to listen to music and to download sound information. MP4 is very useful for video, and in fact this one you're looking at right now will be coded in MP4. It'll also be coded in other formats for other purposes, but I think the one you're looking at right now will be MP4. It's a compression technology with very little loss of quality, and it gives about CD quality reproduction, which is good, and it streams fast. So MP3, MP4 tend to become a widely used standard. MP3 requires MP3 players, and these may be downloaded depending on the operating system. But Windows Media Player, QuickTime, the Apple one for QuickTime, there are many others. And again, if you go online, go through a browser and simply type in MP3 players, you'll find loads of them to download, many of them free. E-commerce, well, e-commerce will benefit from these developments through more effective advertising, catalogue presentations, customer management relations, business-to-business negotiations, and many other opportunities. So, of all the facilities we've talked about on the World Wide Web, virtually everything it does, from email onwards, is facilitating the flow of information, the contact between people, between businesses. So it's a B2B, B2C, etc. All of these contacts will facilitate the growth of business, growth of information, and information, I suppose the underlying assumption is, information is good. So that's the World Wide Web. I think this is the second class in a two-part series. Please look at the part 1 as well. That's all I'm going to do for this session, so thank you for watching.